Hello everybody. In this lecture, we are going to see about the Fourier series analysis. So first we start with the definition for the periodic signal and what is continuous time periodic signal, and we'll see some examples of this continuous time periodic signals. Okay, so what's the definition for this periodic signal? Periodic signal is the one in which the signal gets repeated after some fixed time period. Okay, so it is getting repeated. The pattern gets repeated. Then we call it as a continuous time periodic signal. So this signal has a particular pattern or shape. The continuous time signal is one for which the signal has values at each and every instant of time. So far we have seen this definition. Okay, now we will see the signals. So this is a sine wave. So what's the shape of the sine wave if you look at it? So this is the sine wave. So here it starts from the zero. After that it reaches its maximum value, again zero, then minimum value, and then again zero. So this is one particular shape. This shape gets repeated. So if it is for the first time, this is the first time occurrence, then here you see the second time occurrence is here. So this is again, you have the second time occurrence. Then this is the third time occurrence. See this one, it is occurring for the third time. So here we have the repetition of the same pattern. Then we call it as a periodic signal. Some more examples. Here this is a ramp signal. So this is also having a particular shape. Here you see this is the particular shape. The shape gets repeated. Okay, then it is a periodic signal. And here also you have some more examples. Here you see this triangular wave, the square wave, then half wave, rectifier, sine wave, and then full wave, rectified sine wave. Like that we have so many signals. And what are the important parameters that are related to this any signal? So the parameters are amplitude, frequency, and phase. So what is it? The amplitude is usually represented along this y-axis, and the frequency, actually this frequency is not directly represented in this 2D plot. Okay, so it is an indirect representation. So instead of frequency we have the time. So the time is measured here along this x-axis. This is your x-axis. So this amplitude is measured along the y-axis. The other name for amplitude is magnitude. And then the third parameter is the phase or the phase difference. So it is usually measured with respect to another signal. So you should have at least two signals, okay, if you want to really measure the phase difference. So this is signal number one and this is sinusoidal signal number two. So this starts here, that is this pink color signal starts here and it goes on like this. And this one earlier, it started earlier, right? So here it reaches this x-axis at 0 point, this intersection, after some time period, isn't it? Here also you can check it. Here it reaches 0 after some time period. This blue signal occurs, right? So there is a delay. This delay is taken as the lag. So it is lagging. Which one is lagging? This blue signal lags. Okay. The blue signal lags the pink signal. Or we can say that the pink signal leads. It leads the blue signal. Like that also we can say. Okay. Right. So how to measure this parameters? Suppose if you want to measure this amplitude, here you have to check it along this y-axis. So here you have to check it along the y-axis. So some value would be given here as some a, or you can be given that value as something like some 2, 3, 1, something like that. You might be given some value. So that is the magnitude. So the general representation for this magnitude is, or the amplitude is a, and this may be a function of this t, x of t, or you can have it as f of t or x1 of t. So it may be a voltage signal or it can be a current signal like I of t or v of t. Okay, so it is a function of time. Here it is being represented with the amplitude, or amplitude is the peak value, right? And if it is a periodic signal, another definition is also there, right? I have told you the third, this continuous time signal is the one for which the signal has values at each and every instant of time. That is the definition. So here, this is a continuous time periodic signal. Why? Because if you measure it here, you will be having some peak value A. If you measure it here, you will be having the peak value of minus A. So this represents, the x-axis represents the time period. So suppose if it is some 1 second, and this is your 2 seconds, and this is your 3 seconds, this is 4 second. Okay, so it is 0, 1, 2, like that it is going on. So if you are measuring it at 0th second, that is, this is your time and this is your amplitude. Okay, at this time instant you are having zero value. So if you measure it at 1 second, then it will be having the amplitude of A. If you measure it at 2 seconds, then it is having a value of zero amplitude. And if you measure it along this 3 seconds, then it has the value of minus A. Then if you measure it at 4th second, okay, then it is having the value of zero. So for each and every instant, not only with the particular time period, you can also measure it like, suppose this is A plus A and this is your minus A amplitude. And the time axis can be like this. Instead of this, you can measure it at 0.1 second even, and then 0.2 second, like that you can have very small. Okay, so if you want to measure it along the 0.1 second, then you will be having some value of this amplitude that would be available. If you measure it at 0.2 seconds, then also you will be having some value of this amplitude, not A, okay, some fraction, right? So that would be available. Even if you measure it for 0.25 seconds, then also you'll be having some value or the amplitude. Okay, so at each and every instant, you'll be having the value. So with respect to time, you'll be having some value, right? So then it is called continuous time periodic signal. So this Fourier series is used to analyze continuous time periodic signal. Also, you can do the analysis using this Fourier series for discrete time. But the condition is Fourier series analysis is possible only for the periodic signals. So you cannot apply this Fourier series for aperiodic signal or non-periodic signals. Okay. So with this we wind up the lecture number 1 for this series. Okay. Thank you. Hope you have understood.